Hello and welcome to another RLabs tutorial. Today we're going to be exploring how to create box plots using the ggplot2 package. Before jumping into the specifics of how to code a box plot, let's just consider some of the alternative graphing approaches that are available in R and why ggplot has become such a popular graphing application. Similar to the plots function, ggplot2 has the ability to be coded incrementally, adding line by line, adjusting parameter by parameter slowly, allowing you to bit by bit converge on a better looking figure. Not only this, but it's implemented in a way similar to the lattice package, which means that when you make changes to the axes numbers, labels, and titles, it automatically rescales the whole plot to ensure that these text elements fit onto the panel. This is not the case in the plot function in base R, which means that sometimes when you're using the plot function, you get stuck in this problem where you have to manually go in and faff and adjust the margins of the figure. In other words, these two approaches of gradually adjusting element by element and changing many different parameters of the plot quickly and easily, with the ability of the plot to change dynamically according to how axes and axes labels are changed, makes ggplot a very popular graphing package. So today we're going to be looking at how to use ggplot to produce box plots. To do this, we're going to use the geometric object, which is coded through geom-boxplot. In just one small line of code, we can produce very ugly figures like this, and then we can go on to produce publication quality figures like this one on the right. The data that we're going to be using today to demonstrate the simple code of ggplot of producing box plots is the tooth dataset, which can be found in base R. This dataset looks at the length of tooth growth according to different supplements that have been provided at different doses. Okay, so let's assign to my.data the tooth growth dataset. Let's make an adjustment to this dataset by rewriting the variable dose as a factor. Once this is done, let's read in the package ggplot2, and let's consider the names of the variables that we're dealing with here. Once we have the names of the variables that we're interested in, we can then add these to the plot that we're trying to create. It's very simple, there's just one line of code, but if we nip back to our presentation, we can see how these different lines of code line up to certain attributes. Later on, we'll find that there are many lines needed to program a ggplot graphic object. For a ggplot, there are some distinct elements that we need to be aware of. First of all, there's the creation of the ggplot object. Then there are layers that are added to this, and then you can adjust the global options. The ggplot object consists of a data frame with the addition of identifying variables of this data frame that are representative of the X or Y variables that we're trying to map onto our figure. Then we have layers like the geometric object, whether we're trying to produce a histogram, box plot, or scatter graph. Other layers include facet grids, which allow us to produce panels of graphs according to a certain variable. Statistics that allow us to add more information to our plots, like adding lines of best fit and confidence intervals. Okay, so here we see again that first line of code to produce the simplest box plot from ggplot. I've color-coded a portion of this code to show that the first input for the ggplot is the data frame, and the second input is the mapping of variables of that data frame onto our figure. So we have the aesthetic function, and that takes the variable supplement, which is a categorical variable, and the continuous variable length. And we add to this geom-boxplot. We can then go on and refine this figure by adding a facet grid layer. To do this, we specify the rows, tilde, columns. In this case, we have a dot where the rows are. In other words, we're not having panels going up and down in rows. Then we have a tilde, and then we have the variable dose. This means we're going to separate our data into several columns. So if we look up here, we'll see that there's 3 columns that have been created. So that's one way to show a third dimension, in this case the new categorical variable dose. But an alternative way is to add this to the mapping in the aesthetics call. This is done simply by fill equals dose, which has coloured these boxes according to the amount of dose that was provided. In this case, I actually prefer the fill equals approach and mapping the data to a colour rather than using a many panelled figure, but it's personal preference. I still have one criticism of the colours of this plot, which is that in fact the dose, while it is a categorical variable, these levels within it should be seen as ranked. Obviously 0.5 is less than 1 millimeter and 1 is less than 2 millimeters. To change this, we can create a vector that is my.color, and within this we can assign some new colors. These colors imply that there's a sequential difference between levels of dose. We then call this palette vector using the scale-fill-manual, where we're able to set the values equal the vector that we've just prescribed. In this case, we've actually chosen the colors in quite a neat way. If we go onto the internet, we can go to the colorbrewer2.org website. This is designed by cartographers, and it allows you to select whether you want sequential or diverging colors. It gives you the option to say the number of classes, the number of levels that you have. In this case, we have 3 levels. And you can choose a color scheme that most suits you. And then down here, you can select the exact hex numbers to specify those colors in R. And these colors have been optimized to be colorblind safe and distinct in terms of their luminance. Not only has the scale-fill-manual set new colors to our boxes, but it has also updated the legend. Next, we can try and address the grey background. This is simply done with the addition of plus theme_BW, BW standing for black and white. And this strips and makes the background element blank. The final step to get the figure looking perfect takes a substantial jump in the number of lines of code that have to be written. And this is just because there's many small tweaks that have to be made, such as changing the size of the axes titles, the size of the axes labels, etc. Here you see we've abandoned the theme-BW and replaced it with one that we've manually written, simply plus theme. And we can specify that we want to get rid of the grid lines, get rid of the border, make the background of the figure blank, and set the font sizes for titles of X and Y axis and labels of X and Y axes. In short, ggplot is a great package to quickly produce a graph that displays the information you need. But like coding all graphical objects, it takes a while to move the figure from the information that you want to make it publication quality. Thank you for listening to this RLabs tutorial video. If you found this useful, you may be interested in our free online Moodle course, or check out and subscribe to our YouTube channel.